This video is for the Chapter 8 practice test on Schoology. Question number 1. Solve for the value of x. Leave your answer in simplest radical form, so no decimals for something like this. So what you got to do with Pythagorean Theorem. Okay, we know two sides. We're looking for the third side. The side opposite the right angle is always c. That's your hypotenuse. That has to go by itself. Okay, we're solving this with a squared plus b squared equals c squared. Okay, assign one of the legs to be a, the other one to be b. Doesn't matter which one is which. So for this one, we have 12 squared plus 16 squared equal to c squared. And we're multiplying, or we're squaring those and then adding it together. So we have 144 and 256 that we need to add together. So this one comes out to 400. And we take the square root of both sides, and we have that c is equal to 20. So this one doesn't have a square root in it that we need to reduce. We just have 20 as that the square root of c squared. Okay, number 2. Number 2, okay, same direction. Solve for the value of x. Leave your answer in simplest radical form. This time c is something that we already know. So we have a, we have b. We're doing a squared plus b squared equals c squared. X squared plus 13 squared equals 14 squared. So one step just to square everything. One step to subtract. So we're going to subtract both sides. And we get x squared equals 27. Okay, after you subtract 169 from both sides. We take the square root. The square root of 27 is not a perfect square. So we look for a perfect square that goes into 27. That's 9 and 3. Okay, so that means that since the square root of 9 is 3, our answer is 3 times the square root of 3. Third one, solve for the value of x. Leave your answer in simplest radical form. Same thing. Here's the right angle. That means that 61 is the hypotenuse, which makes it all by itself on one side of the equal sign. Okay, so we have x squared plus 121. 61 squared in your calculator comes out to 3721. Okay, subtract 121 from both sides. When you do that, you get 3600. Okay, and the square root of 3600, that is a perfect square. When you take the square root of both sides, x is 60. Okay, that's how you use the Pythagorean theorem to find a missing leg. Next, using the converse of the Pythagorean theorem, okay, when it asks you to classify something, okay, classify, you have 3 options: acute, right, or obtuse. One thing I like to do is put c first for this. So I find the biggest number, that's c. We're going to compare 41 squared to 9 squared plus 40 squared. I like to put an empty box here and figure out eventually what goes in that box. If it's an equal sign, a greater than sign, or a less than sign. Okay, 41 squared is going to be 1681. Okay, we're comparing that to 81 plus 1600. Okay, what ends up happening here is we get the same number on both sides. C squared is equal to a squared plus b squared. When that happens, we have a right triangle when they're equal. Okay, same directions for number 5. Our biggest number is 20. So 20 squared, all right, we're going to compare that to the size of 10 squared plus 16 squared. We get 400 on one side, 100 plus 256 on the other side. So we have 400 that we're comparing to 356. Since 400 is bigger, that means the hypotenuse is bigger. When the hypotenuse is bigger than the legs squared, we have an obtuse triangle. This one's obtuse. Okay, and then number 6 is just going to be a good example of an acute. Let's go through the steps. 18 is the hypotenuse. It's the biggest one. Put that first. Then a box. We have 12 squared plus 15 squared. 18 squared is 324. Equal to 144 plus 15 squared is 225. All right, so we're adding together the 144 in the 225, and we get 369. 324 is smaller than that. So since the hypotenuse is the smaller side, that's when you have an acute triangle. So the third one, number 6, is acute. Okay, last thing for 8.1, Pythagorean Theorem that we might have to worry about, word problems. Okay, so making your own picture. A town hall needs to build a ramp. The height of the ramp must be 2 feet. So I'm going to draw my ramp. It's going to look like a right triangle. The height has to be 2 feet. Okay, the ramp will start 6 feet from the door. To the nearest tenth of a foot, how long will the ramp be? So along the ground, we're starting 6 feet away from the door. We want to know how many feet the ramp will be. Okay, and it says nearest tenth of a foot, so we are going to be okay with decimals this time. Okay, the ramp is our hypotenuse, so this is C. So just like we were just looking at, we have 2 squared plus 6 squared equal to x squared, since the ramp is what we're solving for. So we have 4 plus 36. Okay, so what we need to do is the square root of 40. Since this is a word problem that asks for the nearest tenth, we don't need to simplify the 40 by breaking it down. We just round it to the nearest tenth, which is about 6.3 feet. 6.3 feet would be our answer. Okay, on to the next page. 2 was all about 30, 60, 90s and 45, 45, 90s. So what we have, okay, 45, 45, 90s, if you're going from a leg to the hypotenuse, okay, what we have is an isosceles triangle, so these legs are equal. Okay, if I know how long the leg is, I just multiply by square root of 2 to get the hypotenuse. If I know the hypotenuse and I need a leg, I'm going to divide by square root of 2. Okay, then if you have a 30, 60, 90, the legs are not the same length anymore. Okay, you have a shorter leg, you have a longer leg, and you have the hypotenuse. Okay, the short leg is half as long as the hypotenuse, so if you're going from the short leg to the hypotenuse, you double. If you're going from the short leg to the hypotenuse, you multiply by square root of 3. Okay, and if you're going the other direction, you divide. So it's about finding which type of triangle you have and then performing that rule. Question 8, find the value of x, leave it in simplest radical form. We're going from, it's a 45, 45, 90. We're going from the hypotenuse to a leg, which means we're going to divide by square root of 2. One thing about this is you're not allowed to leave your answer like that with a square root in the bottom. So we're dividing by that square root of 2. What we do is we rationalize, we multiply by whatever that square root is in the bottom over itself. So square root of 2 over square root of 2. That gives us 26 square root of 2 up top. On the bottom, square root of 2 times square root of 2 is 2. It's the square root of 4, which simplifies to 2. Okay, then we're allowed to take the 26 and the 2, since they're both outside of a square root, and divide those. So our answer for this one is 13 square root of 2. And number 9, find the value of x, leave it in simplest radical form. Okay, again, 45, 45, 90. This is a leg. We're looking for the hypotenuse this time, which means I need to take this and multiply it by the square root of 2. Okay, what happens with that? We have 5 square root of 2 times square root of 2. These two are going to make square root of 4, which is 2. This is 5 times 2, so our answer is 10. Next one. Find the value of x, leave it in simplest radical form. This is a 60, which means this is a 30. So first thing I would do is label the hypotenuse, which one is the shorter leg, which one is the longer leg. Okay? They started us with the hypotenuse. If you don't get started with the short leg, that's the next thing you find. Okay, to get from the hypotenuse to the short leg, we divide by 2. That's the shortcut. So that means that the short leg is equal to 6. Okay, that's not what x is, so that's a trick answer in your answer bank. What you need to do is take that 6 and get the long leg with it. What you do is you multiply by square root of 3. So 6 square root of 3, that's already in simplest radical form, so that's our answer. Next one, find the value of x, simplest radical form. So this one doesn't have any angles on it, but I know that the legs are the same length. That means this is a 45, 45, 90. So I know that I have the hypotenuse, and I know that I'm looking for a leg, so I need to take the 6 and divide it by square root of 2. Same steps happen here. 6 over square root of 2 is what we're looking for. Okay? We have to rationalize this one again. Can't leave a square root of 2 in the bottom. We have 6 square root of 2 on the bottom. We canceled out the square root. All that's left is a 2. 6 divided by 2 is 3. So we can say that this is 3 square root of 2. Next one, question 12. Okay, this one's a 30, 60, 90. Okay, this one should go pretty quickly. We have the short leg, we need the long leg. This is the hypotenuse, but we don't need it. The short leg times square root of 3 is x. So this one is 5 square root of 3, and that one's done. Number 13. Okay, find the value of x. So for this one, we are going the other way. This is the long leg. This is the short leg. I need to divide by square root of 3 instead of multiplying. So I know it's a little blurry, but this long leg is 12. So the short leg is 12 over the square root of 3, okay, which is a trick answer right here. You can't leave a square root in the bottom. So we multiply by square root of 3 over itself. Okay, we get 12 square root of 3 on the top, just a 3 on the bottom. 12 divided by 3 is 4. So this is 4 square root of 3, which is our answer here. Okay, so that's everything for 8.2. Okay, moving on to the next page. Lesson 8.3 was all about SOHCAHTOA trigonometry. Okay, so SOHCAHTOA, that tells you what, when to use sine, when to use cosine, when to use tangent. Okay, sine is the ratio of opposite side over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. This one says complete the ratio using the diagram given. So you don't have to actually solve anything for 14th. What we're looking for is the sine of angle B. So the sine of B, here's angle B. Okay, the sine of B is the side opposite of B over the hypotenuse. Okay, so with this one, it's 24 over 26. You did not need to reduce it. Okay, just 24 over 26. Okay, next one. This time we want the cosine of B. Okay, so we have B here. Cosine is adjacent over hypotenuse. 10 is the side that's adjacent to B. 26 is the hypotenuse. So this is 10 over 26. You don't need to simplify. Okay, next one, last one, similar. Okay, tangent of A. Here's A. Tangent is the opposite side over the adjacent side, which is 10 over 24. Don't need to simplify or reduce. All right, what we use trig for is to be able to find a missing side or to be able to find missing angles. So this one's missing a side right here. Okay, they gave us that this angle is 40. Okay, what we need to do first is label the hypotenuse, the opposite side, and the adjacent side. There's nothing by the hypotenuse, so I'm not going to use it. So all that I have left is the opposite side and the adjacent side, and that's where SOHCAHTOA comes in. Okay, we're going to use tangent because that's the one that involves O and A. So we're going to choose tangent. The way that we set this up, we have tangent of whatever angle they gave us, this time it's 40, equal to x, the opposite side, over A, which is 20. Okay, opposite side over adjacent side. When the number is on the bottom like this, all we need to do is multiply both sides by 20. That cancels these out here. And we have 20 times the tangent of 40 as our answer. That's what we go to the calculator with. So this is 16.78. We're rounding to the nearest tenth. So 16.8 is going to be equal to x. Okay, question 18. The value of x, round to the nearest degree, that's the nearest whole number. So this is an inverse trig problem. Here's the angle that we care about. First thing, label the hypotenuse, the opposite side, and the adjacent side. There's nothing by the opposite side, I don't need it, so all that's left is A and H, which is my hint to use cosine. The cosine of the angle, that's x this time, is equal to the adjacent side over the hypotenuse, 12 over 13. Okay? that means that x is equal to the inverse cosine of that same fraction. The inverse cosine of 12 over 13. Make sure you know how to punch that in. Okay, that gives us that x is equal to 22.6. That rounds up to 23. So this is, you should have put 23 in there as your answer. On to question 19. Now we're finding a side again. Okay, so we have an angle of 48. Here's the hypotenuse. Here's the angle we know. X is the opposite side compared to the 48, and then 5 is the adjacent side. So we have O and A. We don't care about H. When you have O and A, you use the tangent. Okay, tangent of 48 is equal to the opposite side, which is X, over the adjacent side, which is 5. So since the number's on the bottom again, we multiply both sides by 5, and we're on our calculator step. So when you do 5 times the tangent of 48, again, you got to know how to punch that in. We end up with 5.55, okay, and that's going to round to approximately 5.6, nearest tenth. Number 20. Find the value of x. Now we're going to the nearest degree again. So here's the angle we care about. This is the opposite side. This is the hypotenuse. When you have O and H, you use sine. Sine of x equals 11 over 23. So we go to the calculator with x is equal to the inverse sine of 11 over 23. We're rounding that to the nearest degree. Okay, so that gives us that x is 28.6 degrees, but you should be typing in 29 degrees. Number 21. Okay, last one from 8.3. Okay, we're looking for a side length, so we're using regular trig. We have the opposite side and the adjacent side. So once again, we're using that tangent piece. So we have tangent of 54 equal to opposite x over adjacent 8. Multiply both sides by 8. And we cancel over here. 8 times tangent of 54 is what we're looking at, which is 11.01 equal to x. If we round that to the nearest tenth, that's 11.0. On to the next page. 4 is more trig. It's related to SOHCAHTOA. Okay, it's about angles of elevation and depression. So what this first one is matching, so the answers might be jumbled up when you try it. Okay, but angle 1 is looking down from the bird to the balloon. So what I'd be looking for is the one that says angle of depression from bird to balloon. That would be this one. Okay, angle of depression from bird to hot air balloon. So for me, that first one is, I would type in B. Okay, angle 2 is just the opposite, hot air balloon back up to the bird. So this angle 2 is the angle that the person would have to look up to see the bird. So I'm looking for angle of elevation from hot air balloon to bird. So for me, that would be option D. Angle 3 is looking down. Okay, how many degrees the person has to look down to see the ground. So depression from balloon to ground. Angle of depression from the hot air balloon to the mountain. Oops, depression for that, not elevation. Okay, so for me, that would be option H. And then angle 4 is just the opposite. It's from the mountain at the bottom up to the balloon. So looking up there, so that would be the elevation piece. So that would be G. Okay, with this section, I'd be more worried about word problems. Okay, so we'll look at those, draw a picture, and then go from there. So a couple is taking a hot balloon ride. After 25 minutes, they measure the angle of depression from the balloon to its launch place at 16 degrees. So at that point, they're 180 feet off the ground. So we're 180 feet off the ground. This is where we started. Okay, this is where we launched. This is where we're at now. Okay, at that point, they measure the angle of depression to be 16 degrees. Remember that angles of depression are actually outside of the shape. Okay, well, an angle of depression of 16 is really an angle of elevation of 16 as well. So the 16 actually goes at the bottom of the triangle, not at the top. Okay, the question is, how far is the balloon from its launch place? Here's the balloon, here's the launch place. It doesn't say the distance along the ground, so what it means is, let's find this hypotenuse. This is x. Okay, so we're solving for that. We have 16 here, that makes this opposite, and this is hypotenuse. So we're doing the sine of 16 equal to 180 over x. This is the first time on this video we've had the x on the bottom. So when that happens, it's a couple of steps. First step, multiply both sides by x. That cancels these out. Okay, then what we have is x sine of 16 equal to 180, and I need to divide both sides by sine of 16, and that cancels out these sines of 16. So we're at our calculator step. What we need to type in is 180 divided by the sine of 16, and that's 653. We want nearest tenth. That's going to be 0.0 feet. So a couple tricky things about that. The angle of depression is the same as the angle of elevation, so the 16 actually belongs in the lower right part of that triangle. Question 24. A surveyor is 300 feet from the base of an apartment building. Okay, so we're 300 feet away from a building. That's like this. Okay, we're standing here. Okay, the angle of elevation to the top of the building is 24 degrees, so that's this angle of elevation. And their angle measuring surface is 5 feet above the ground. So our building, okay, this is actually the ground. So let me modify this a little bit. Okay, this is the building, this is the ground. Okay, so we're standing here. It's really like from our eye level, which is 5 feet above the ground. It's kind of like how tall we are. Okay, what we have to do is remember to add some stuff in. So this is just the ground that we're standing on. Okay. What we need is the height of the building. With these types of problems, when you find x, you're only finding this much of the building. So what we need to do is find x and then add 5 more feet, because this piece is going to be 5 more feet right here. Okay, so we have to find x and then we have to add 5. So from our angle 24, x is the opposite side, 300 is the adjacent side. We choose tangent. This is the tangent of 24, equal to the opposite side x over the adjacent side 300. So we're doing 300 multiplied on both sides. And we're typing in 300 tangent of 24. Okay, that's equal to 133 we're doing nearest tenth again, so 0.6. That's equal to x, but we need to add 5 because we're starting from a point that is 5 feet off the ground. So if you forgot that step, that might be why you're here and watching the answer to number 24. Maybe you forgot to add the 5 feet off the ground that we are. Okay? All right, last page is just a couple more problems. Okay, one thing you might see in some mixture view is kind of a back-to-back triangle like this, or like number 26. We'll talk about them one at a time. So what's happening is I need to find x and y. If I'm looking at this triangle, I can't use Pythagorean Theorem to find x or y because I only know the 14. So I need to figure out which one I can find first. What I need to do, I can find y first if I look at this triangle. Okay, and what that is going to be Pythagorean Theorem. I know 2 of the 3 sides on that blue triangle, where 12 is the hypotenuse. So the first step is to actually find y. Y squared plus 6 squared equals 12 squared. Okay, everything says simplest radical form for this one, so we're not going to use decimals. We're going to use simplified square roots, simplified radicals. So this is y squared equal to 108. We take the square root of 108, okay, which is a decimal, so I need to break that down. if I divide 108 by 36, I see that 36 goes into that 3 times, which means that this is 6 times the square root of 3, which should be one of the options in our word bank, and it is right here. Okay, so this is what y is. Now that we know that that's 6 square root of 3, okay, now we have enough information to find x with the Pythagorean theorem. Okay, so what that is, 14 is c for this one. So I have x squared plus, and this is going to be tricky, but 6 square root of 3 squared equal to 14 squared. Okay, x squared. So what happens here is the squared is going to go to both of these things. 6 squared is 36. Square root of 3 squared, that's square root of 3 times square root of 3, which is 3, okay, equal to 14 squared, which is 196. So what we have here is x squared plus 108 again, equal to 196. That means that when I subtract 196 minus 108, I end up with x squared equals 88. I'm taking the square root of that. Okay, a perfect square that goes into that is 4 22 times. So this one is 2 times the square root of 22. So a little bit difficult in terms of the algebra on that one, but that's really good practice for us. Okay, last one for our video. Find the missing sides in the triangle. Again, simplest radical form. All right, so I have a 30, 60, 90 right here. Okay, and I have a 45, 45, 90 right here, even though it's definitely not to scale. Okay, something a little bit weird about this triangle is that the green one, the legs are supposed to be the same length, but they really don't look the same length. So 45, 45, 90 over here. If this is a 14 right here, that means x has to be 14. These legs have to be the same. Okay, and what I need to do is I'm going from leg here to hypotenuse here. So I need to multiply by square root of 2. So that means y is 14 times the square root of 2. All right. Another piece of this that's not quite to scale is that this is actually supposed to be the short leg of the 30, 60, 90. And this is the long leg. Remember, between the 60 and the 90 is your shorter leg. So to get the hypotenuse, w, I need to take 14 times 2. So w is 28. And I need to take 14 times the square root of 3 to get the longer leg. So that's going to be what z is. And that should be it for this one. All those answers are options in the word bank, so it looks like we did everything correctly. Thanks for watching. Let me know or your teacher know if there's any other questions. Good job.